Cylindrical and spherical coordinates. We're going to first start with cylindrical coordinates. So we have below given points A being 1 square root of 3, 2, B negative 2 square root of 2, 2 square root of 2, 4, and C being 3, negative 3, 7 in rectangular form. So we have to find the cylindrical coordinates for part A here. So we're just going to use these equations we have above. Now we're going to use this side right here because we know our x's, y's, and z's. So therefore, we're going to be taking this rectangular form, which are the x's and y's, and we're going to be turning it into r's and thetas and z's. So we're going to be going that way. So we're going to be going from rectangular to cylindrical. So essentially the way this is working, the cylindrical coordinates works just like the polar. So these equations up top here, these are really the polar equations that we talked about in the past. And there's no difference here except all we're doing is adding a height to that, a z. So that's what we're going to deal with here. So we're only going to be dealing with this x and y here for the conversions. And notice here it says z equals z. So our 2 is just going to be 2. So that's how that's going to work. So it's just going to be the x and y that we're concerned with here. So we have this r squared, and this r squared equals x squared plus y squared. So we're going to use this one here, and my x being 1 for this a, so it's going to be 1 squared plus square root of 3 squared. And that's going to be 1 plus 3, which equals 4. So this implies then r is going to equal plus or minus 2. So I'm just going to leave it like that for now. So now what we're going to do is we're going to talk about the theta now, because the coordinates we need for cylindrical are r, theta, and z, because z equals z. So we need an r, a theta, and a z here. So that tells us then for theta, I'm just going to set up the other formula. Now I'm going to use this one here to find theta. So that's going to be the tan of theta equals, and my y is square root of 3. So that's going to be square root of 3 over 1. So it's really just a square root of 3. And that implies my theta then is going to equal, so that would be pi thirds. All right, so now we have our r, theta, and our z. So our rectangular coordinates for this first point A, and I'll just write A here, is going to be 2 pi thirds, and z is going to be 2. And that just comes from the original point there. That doesn't change. So that's what I end up with for my cylindrical coordinates for my point A. Now I have to consider the negative, and that's why I didn't discount it right away, the negative or positive 2 here. Simply because I had to think about what quadrant, what octant I'm in. Not quadrant, but octant. And that would determine if I'm going to use a negative or positive r, what my angle is that I'm using. And we can see that this is going to be in the first octant, so all of my components are going to just stay positive. And my pi thirds is going to stay between 0 and pi over 2. Okay, let's take a look at the next point now. So the next point we're going to look at is point B here. We're just going to do the same thing here. So I'm going to have an r squared equals, and then I'm going to take this negative 2 root 2 squared plus 2 root 2 squared plus, oh, there's no plus. Okay, that equals. Now this is going to be 4 times 2, and I'm just going to write this step out here. Some people have a little difficulty with the radicals still. So that's going to be 4 times 2. And where this comes from is I squared the negative 2 here, and then I squared the square root of 2, and that's why I got a 4 and a 2, because a square root of 2 squared is 2, and then a 2 squared is 4. All right, so this is going to actually equal 16. So this tells me then my r is going to equal 4. And we can say plus or minus 4 for now. Okay, now we're going to take a look at tan of theta. Now tan of theta is going to be actually 2 square root of 2 over negative 2 square root of 2, and that actually equals just negative 1. And if I know my trig values, I know theta, where we get negative 1 for tangent, is either going to be 3 pi fourths or 7 pi fourths. Okay, now it just depends on what octant I'm in, and I'll determine that when we actually think about where we're going with this. So if I think about the point here, my x is negative 2 root 2, which is approximately negative 2.8. So that's going to be back here because my x is negative 2.8. So it's back here somewhere. And then my y value is positive 2 root 2. So it's going to be over here. So my point is going to be above this line here. So it's going to be back here. It's going to be in that second octant. So what that means for us then, it's going to actually be about there. Oh, and that goes up 4. Sorry, a little bit higher. Okay, but anyways, you get the idea there. So I'm back here somewhere. So being back there, that tells me I would be in my second quadrant. So actually, I can think of this point, or this angle for my point. Okay, so that's going to be this 3 pi fourths here. And then I can use the positive 4 here. So my pair for this, or my point for this, is going to be B. We're going to have 3 pi fourths. And then my Z is just my Z, so it's going to be 4. So that's going to be our point B. Now for C, the same thing. So we get our r squared equals, and I'm just going to write 9 plus 9. And that's going to equal 18. And this tells me my r then is going to equal plus or minus. And I'll just keep it positive and just deal with the angles, so we don't have to worry about that right now. So 3 square root of 2 once I simplify it. Okay, and then from there I get my theta now. So I have the tan of theta equals, and that's going to be negative 1. I get this negative 1 again. So then for theta, my theta can equal 3 pi fourths or 7 pi fourths. And this one is actually just going to be the 7 pi fourths, because if I think about where my point is at, my point is going to be up 3, so it'll be here, and then negative 3, which is over here. So my point's going to be over here, not actually on the xy plane, but it's going to be up from there. But I'm going to take the two components here, and that's what's actually going to give me my theta, though. And we'll worry about Z in a minute, so that's why I don't worry about going up from there. We don't have to worry about exactly where the point's at here because of that. We're just dealing with the x and y plane in a sense here. Okay, so anyways, so that tells me this is my 0 here. So to go all the way around there, that's where my 7 pi fourths is going to be. Because if I went all the way around, that would be 2 pi, which would be 8 pi fourths. So it's going to be a pi fourths less. So therefore, it's going to be this one we're going to use here, that 7 pi fourths. So then my C then is going to be 3 square root of 2, comma 7 pi fourths. And then my Z is Z, so that's going to be 7. So now what we're going to do is we're going to graph these points. But we'll do that in the next video.